Great to see you here again. My name is Luc de Custer, founder of the Custer Academy, and in this video I will talk about critical chain project management. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Now, basically, the critical path method was developed by Elijah M. Goldratt in his book Critical Chain Project Management, and it looked at different ways, in fact, to improve project performance. Mr. Goldratt has done very interesting work related to operations and project management, and he wrote very interesting books which I would recommend to read. Now, the book Critical Chain Project Management, which he wrote in 1997, he introduced this new method to improve the outcome of projects. Another of his contributions, very important contributions, and we will look at it also in this video, is the theory of constraints. Now, what is the value of critical chain? Critical chain project management is a method in which Goldratt identified main issues with the critical path method. The critical path method assumed that resources were not limited and the planning is done without taking the resources into account. The critical path and the Gantt chart were used to add resources, and later resources issues were resolved, leading to parallel tasks and people being allocated to them. So people were working on parallel tasks. The achievement of Goldratt is that for the first time he addresses both the human and the algorithmic side of project planning. And in his approach is in fact considering that resources are limited available, and we look at resources which are important for our project, and typically those resources are creating the issues on the projects. Now, when we look at human nature and estimation, people may be optimistic or pessimistic, but when you are overly optimistic or too pessimistic, it can lead to problems when you apply this to projects. Goldratt states that unless we are careful, we often get the opposite of what we expect. The element the main thing that Goldratt identified in his book are in fact reasons why the critical path method was not working the way it should. First of all, we talk about estimations. People tend to overestimate. They put too many time in the activity just to be sure that they will finish everything on time. They also add some extra time because they expect that the management will reduce the duration, so they anticipate this. There is the student syndrome, very well known by students. I see many times a student going, "Oh, we have exam today," so they forgot, or they start to study too late and then they run into problems. It's the same thing when your estimations are too, let's say, pessimistic, it's taking too long, you think you have time enough and you postpone the work, and then you encounter problems which lead to an additional delay on the activities. Parkinson law, which states that when we have a time, we typically adjust the effort so that we finish the work in the allocated time. Multitasking is an issue. There are ideas that multitasking is really working well, but we've already seen it when we looked at Agile before, that multitasking is in fact slowing down. And when people are working in parallel on different activities, it has a negative effect on the total duration of the work and the project. No early finishes. When people finish early, it's not there is no advantage taking from them. People typically or let's say there are other activities which are not finished. A lot of reasons why we don't have any early finishes. It's not really the way it should be. We don't like it, but it's happening and it creates some issues. Backward planning, we look at the planning and we calculate back and we start from the idea, when does the project have to be completed? Typically, the sponsor has an idea when the project should be completed, and that should be the starting point of the calculation. Now, we did a backward calculation, and what we are doing here is a backward calculation from the expected finish time of the project, and we calculate backward to the start of the project. And there we see what is possible and what is not possible. This also provides us the idea what's the latest time the project should start, so we can communicate that to the people and say, if you want to have your project finished by this time, you will in fact have to start at a certain time. If you start later, there will be problems finishing your project. As late as possible planning is another way, is to move the planning of the activities as late as possible. There are some advantages to this. We reduce the work in progress because the activities are executed later. Costs are moved to a later time, a better financial performance. The team is more experienced later in the project. There are less errors and less rework expected. And basically we work faster and we have a better overall project performance. There are some disadvantages. The main one is that the further we move the activities to a later date, we have less slack, and in the worst case, all activities would be on the critical path. Now, when we're looking at the constraints, we have to define the constraints. What are the constraints? Well, constraints are these elements that are limiting our performance. And we also refer to it as the weakest link or the bottleneck. Now, what we can consider is cost and throughput constraint. When we look at cost, we have our budget, but throughput is another constraint. How much work are we completing in our project with the work that we are doing, the work that we planned? How is this evolving? Now, when we consider a project or a production, a process, we must find out what is preventing us to perform better. When we look at constraint, we have to have the courage to identify the real issues. We have to know what is going wrong and address those real issues. Hiding the issues is not a solution. It will only lead to more problems in the project. The theory of constraints as defined by Goldratt. First of all, we have to deal with identifying the constraints. So the first thing to do is identify the system constraints, and they can be physical constraints or policy constraints. Decide how to exploit the system. How will we strengthen the weakest link? For example, if we have a link in production, we have to make sure that the products that are sent to that weakest link, that they are of good quality. Otherwise, the weakest link, the bottleneck, will work on products which are already defective and will create more problems later on. We have to subordinate everything to the above decision. We concentrate on the constraint only and not at the other elements. And then we elevate the system constraints. We try to find additional ways, for example, hiring more people, putting more machinery there, and so on. When we have a look at a bottleneck in production, it's the easiest to explain. We have 4 steps. We have a step at 1,000 units per time, 5,000, 300, and at the end, 1,000. Now, what do we see here? We have an input of raw materials for 1,000 items, and we only have 300 items that are completed. Now, when we look at the different steps, we see that the step 1 provides 1,000 units per time to step 2 as capacity of 5,000, so they go through. There is nothing waiting there. They go to step 3, which is in fact the step with the lowest capacity. We feed that step with 1,000 units, but we have a problem. We can only use 300 of those units to go through the next step, so we are producing 300, and we only have 300 at the last step, so all the units received will be processed immediately, and we see that even we have a high capacity when all the machines are working at the highest capacity, we still only produce 300 items per time unit. There is high WIP, there is a lot of work in progress, certainly in this case, in front of the third step. We can have quality issues, losses, and we may not be able to supply the customer. Now, when we look at the bottleneck and the breakdown, we have a first case here. This first case is where this step breaks down. Now, when this step breaks down and we have, let's say, it's a limited time, what we see is that before step 3, we still have work in progress, which is going through because we create WIP 700 units per cycle. There is nothing, there is nothing produced by step 2, but step 1 is providing those units, and since step 2 has the higher capacity, we can, recuperate the lost time. We still have 300 units output, and we basically don't have any significant losses. Now, this is only valid when the step that breaks down is repaired in time. If it's taking too long, then the WIP in front of the bottleneck will disappear, and now we have a second bottleneck. But let's assume that we can repair this step on time, then there is no problem at all. Now we have a second case. Now the bottleneck breaks down. Well, here we have a big problem because we create more WIP in front of the bottleneck, but nothing is coming through anymore, and the production falls to 0. And that loss cannot be recuperated anymore. Now, what we have here is that we have losses when we have, for example, a total production of 300 euro per minute, total production that we have. Well, the fact that the bottleneck is down, we lose per minute 300 euro. Now, I had some companies where we were discussing this, and there were some bottleneck processes where the engineer said, okay, I will look at it tomorrow. Basically, they lost 300 euro per minute till the next day. You can imagine how the cash flow situation of that company is going. It's very important to identify those bottlenecks and identify what the financial impact is on the total work that we are doing. Now, once we have the project, when we're looking at all the elements, we can define buffers. Now, in our case, we have 3 paths. And what we did with the buffer when we looked at the estimations, we make an estimate being 90% probable, but then we go to the 50% probable duration. We take the difference of the durations and we divide it by 2, which gives us buffers. The project buffer we put on the critical path, and on the non-critical path we put feeder buffers. We have the same principle here. And basically when we are working, the feeder buffers protect the critical path from delays on the non-critical path, but once they are not enough, we still have the project buffer that we can use. The advantage of reducing the durations to their 50% estimate and having the project buffers gives us a better way to deal with the project. The Parkinson law is limited to a reduced duration if we finish earlier. The student syndrome is happening faster because we have to finish it. All the advantages here bring us the possibilities to finish the project earlier. Based on this, we can also identify the critical chain. We have here the different people. Harry Potter is working here on the critical path. On the different paths, we use the feeder buffers to move the activity. So Harry Potter is only working on one activity at a time. And the critical path is the green line where we connect Harry Potter. Harry Potter is in fact that special resource that we have to consider that we need to manage properly. If Harry Potter would be working in parallel on these activities, then it would create a lot of problems. There would be a lot of delays. The project buffer is also very interesting. When we have delays on the project, we communicate the project buffer to the customer, and as long as we still have buffer, we don't have to report any delays to the customer. So we don't have all that stress related to the end time, the duration of the project. The last thing is about the feeder and project buffers. Here we had some calculations that we did. So we have on the top the 90% durations. We see that the project duration is 54. On the bottom, we have the 50% durations. They're not exactly 50%. Let's say that we estimated them. And we can include the project buffer, which is in this case 9 periods, which leads to a reduced duration. Instead of 54 periods, the project will finish in 45 periods. And we also have a feeder buffer of 9 periods when we consider this exercise. So that was it for the critical chain project management. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you, and I'm looking forward to seeing you in the next videos. Bye-bye.